Hello students, welcome back to my YouTube channel. Today we will discuss the question answers of this chapter energy, and today will be the last video or the last lecture about this chapter. And today we will try to discuss as many as questions as possible. Some of the questions answers have been discussed in the previous videos. That's why I always say please watch those previous videos, and when you watch it, please watch it completely. Do watch the videos completely. Now these questions which I will discuss today, I'm going to discuss, the notes will not be available. If you want, what you can do is that take a pen and a paper and you can just tick the answers as per, and if you have the book, just tick the answers over there. But firstly, pay attention how these questions and how the answers are coming. Okay, now if I see the first question, which of the following has both kinetic and potential energy? So a body will have both the kinetic and potential energy. I need to know which body will have both kinetic and potential energy. So let's start with option C. An athlete when running at a full speed. So athlete is running, and when it is running, it's running. Running means what? Motion. Motion means what kind of energy? It will have kinetic energy. So if the body has only kinetic energy, this body has only kinetic energy but no potential energy. So an athlete running at full speed has no potential energy, only it has kinetic energy. So this is not my answer. Let's come to this part B. Bent bow about to shoot an arrow. So when you have a bow which is about to shoot, now that bow is stretched, the arrow is stretched in the bow. So that time any stretched object will have what? Will have conditional potential energy. If you happen to notice video number 2, any stretched bow or a compressed spring will have what kind of energy? Conditional potential energy. So this has only potential energy. So this thing has only potential energy. So this is also not my answer. But a flying bird has both kinetic and potential energies. You can see when a bird is flying, it is at a certain height. When the bird is at a certain height, it has what? Potential energy. It has potential energy. Also, the bird is moving ahead. The bird is also going forward. So as it is going forward, that will have kinetic energy. So a flying bird will have potential and kinetic energy. So this is my correct option. So option D is also not the correct one. None of this. So because we got answer. So flying bird will have both potential and kinetic energy. I hope you understood this question. Now coming back to question number 2 of MCQ type, a compressed spring. The first question, if I see the compressed spring, so if I take a spring and I compress it, okay, I take a spring and I compress the spring to this size, okay, smaller size. What energy the body will have right now? First option, will it have vibration energy? Is the compressed spring vibrates? No, the compressed spring never vibrates. So no vibration energy. Second option, kinetic energy. Does a compressed spring moves? No. A compressed spring doesn't move. If there is no motion, no question of kinetic energy. So this is wrong. This is also wrong. Muscular energy. A compressed spring has muscles. Does that tell me if a compressed spring does have muscles or not? We have muscles. Compressed spring doesn't have muscles. So there is muscular energy is out of the box. So left with only one option, potential energy. Does a compressed spring have potential energy? Yes. We have learned when you compress a spring, what energy it stores? Conditional potential energy. Conditional potential energy. So correct option is this, potential energy. Now going to question number 3. Which of the following does not store chemical energy? Does not. Very important. Does not. So let's come over here. Does a torch store chemical energy? Yes. A torch battery, the batteries of a torch has chemicals inside them. If you open a battery, you will find certain sort of chemicals, things are there. So those are chemicals which by the chemical process, chemical energy gets converted into electrical energy and the torch lights. So yes, a torch has chemical energy. So this is not my answer because the question is not store. So this has store. Firecrackers stores chemical energy? Yes. A firecracker, if you open the firecracker, you will find some kind of gunpowder, all these things are there. So those are chemicals. A firecracker has chemicals. If it has chemicals, obviously it will have chemical energy. So this is also not my answer. This is also wrong. Potato. Potato means food. Does food contains chemical energy? Yes, all food contains chemical energy. So potato is also not my answer. But does a stretched spring has chemical energy? No. We have learned a stretched spring or a compressed spring will have what kind of energy? Potential energy. So this is the correct option. Which of the following does not store chemical energy? A stretched spring does not store chemical energy. So a stretched spring does not store chemical energy. So this is my correct option. Now, question number 4. Which of the following is not a fuel? Not a fuel. So, let's come over here. Kerosene, is it a fuel? Yes, kerosene is a fuel. Why? Because it has chemicals inside it. So, kerosene has chemical energy. If it has chemicals, it has chemical energy. So, it becomes a fuel. So, kerosene is a fuel. So, this is not my answer. Natural gas. Natural gas, does it has chemicals inside it? Yes, natural gas is combustible. It catches fire. So it contains chemicals. So it is a fuel. This natural gas is also a fuel. So this is not my answer. Natural gas is a fuel. Coal, is it a fuel? Obviously, you know, coal is used to cook food. Okay, in village areas. So coal catches fire. So coal has chemicals. So coal acts as a fuel. So coal is also a fuel. But talking about candle, does candle contains any kind of chemicals? No. Candle doesn't contains any kind of chemical. That only melt only, and the thin that small wick is there, that wick burns. Okay, so candle doesn't have any kind of fuel. It doesn't have any kind of chemical. So I can say, which of the following is not a fuel? A candle. A candle is not a fuel. So the not a fuel, so candle is not a fuel. So this is my correct answer. So I think you got question number 2, 3 and 4 correctly. Now coming to question number 5. Which is the best example of conservation of energy? Which is the best example of conservation of energy? Now if you look at the first example, first option, the arrow shot from the bow. And if an arrow is shot from a bow, the arrow, after it is shot, the arrow flies forward. If the arrow flies forward, then the only energy it has what? So when it is shot, before that the arrow was having potential energy. Okay, first the bow was having potential energy, and as we release the arrow, all the potential energy in the bow gets converted into kinetic energy. So potential energy gets converted into kinetic energy. So see, you can see conservation of energy doesn't take place because potential to kinetic only happens. A man cycling up the hill. If I am keeping on cycling up the hill, then what happens? I become tired. I happen to become tired. And if I become tired, what happens? My energy is decreasing. My energy is decreasing. If my energy is decreasing, so what happens? Am I getting the energy back? No, I am not getting the energy back. My energy decreases if I keep on cycling uphill. So over here, energy decreases. Energy decreases. Energy happen to decrease. So over here, option number D, a flying stone smashes a window panel. So if I take a stone at this point, as I'm trying to throw, my hand is having what? Potential energy, and as I throw the stone, all the potential energy gets converted into kinetic energy. So see, as I throw, all my potential energy in my hand gets converted into kinetic energy. So over here, potential energy gets converted into kinetic energy. So conservation of energy takes place? No. Potential energy gets converted to kinetic energy. So neither this is the correct option, this is the correct option, neither this. But looking at option B, a swinging pendulum. Just now, before this lecture, you have studied. In swinging pendulum, what happens? Pendulum over here, potential, kinetic, potential, again potential, kinetic, potential, potential, kinetic, potential. So continuously potential energy to kinetic energy and kinetic to potential, and again coming back. So you can say potential to kinetic to potential, again from back from potential to kinetic to potential. So conservation of energy takes place over here. So potential getting converted to kinetic, kinetic getting converted to potential, again potential gets converted to kinetic, kinetic getting converted to potential. So this is my correct option. So this is my correct option. I think you understood the MCQ type. Now let's continue with the fill in the blank questions. Now these are the 5 fill in the blanks that we have in our book. Now coming to the first one. The region around the magnet has dash energy. I think I have explained that part to you. A region around the magnet has magnetic energy. So this answer becomes magnetic. The region around the magnet has magnetic energy. Second question. A body makes use of chemical energy of food through the process of respiration. Okay. Respiration. Answer is respiration. Don't think answer is digestion. No, digestion is not the process. Digestion is just the food is getting broken into small part. But after the food breaks into small parts, then we have to extract all the energy from the food. So that is done by the whole process of respiration. You will study those things in much details in your biology part. Okay, when oxygen comes and food gets broken. So this is the process. Just know that process is respiration. Plants absorb dash energy to make food. Plants absorb, I think this is very easy. Plant absorb light energy. If you write sunlight energy, that is also not wrong. Light energy, sunlight energy, same. Okay, you can write sunlight energy also. Or if you write something like solar energy, that is also correct. Light energy, solar energy, both are correct. Sound is produced when something vibrates. I have taught you, when only body vibrates, sound is produced. The SI unit of work and energy, just previous to this video I have taught you this thing. The SI unit of work and energy is called joule. Okay, it's called joule. So I think all these 5 finger blanks is clear to you. Now let's come to the true and false. Now we will do the true and false. Okay, I've written a little small because I have no space. Just watch it at a higher pixel, 480p or 360p. Hold your mobile in a horizontal way, you will be able to see it. First question: liquids and gases can have kinetic energy. See, liquid flows. If a liquid is flowing, it has motion. Motion means what? It has kinetic energy. So liquids have kinetic energy, that part sure. What about gases? Yes, gases also flows. Air is flowing, breeze, winds. So air also flows. So air, if it is flowing, that means it has motion, and since it has motion, it has kinetic energy. So liquids and gases can flow. If it can flow, both are having kinetic energy. So this statement is absolutely true. Second question: when a body does some work, its energy decreases. Yes. See, I told you, when I am doing some work, see, I am pushing this wall. I'm trying to push this wall. As I'm pushing the wall, what is happening? I am doing work. If I am doing work, if I keep on pushing the wall for say 2 hours, okay, after 2 hours I will become tired. If I become tired, means what? My energy is decreasing. So if I do work, so if a body does some work, so I am the body and I am doing some work. See, pushing the wall is a type of work. Okay, kind of type of work. My energy will decrease. So if energy decreases, will energy decrease? Absolutely, it will decrease. So this statement is completely true. Third question: the energy the body acquires when it is raised to a height is called kinetic energy. Height, therefore height. When it is raised to a certain height, this thing is raising to a certain height. Now what energy the body has? This body has potential energy, because at a height only the body has potential energy. So this is false. Okay, this is not kinetic energy, this should be potential energy. So this statement is false statement. Fourth question. Heat is produced when work is done against friction. Yes. See, my hand, rubbing it, rubbing it. When I'm rubbing my hand and this hand are in friction. And as they are in friction, heat is getting produced. My hands are becoming warmer. So, heat is produced when work is done against friction. Absolutely true. This is true. This is true statement. Now, muscular energy is a form of chemical energy. Our muscles, we have energy. We can lift certain object or do anything. Okay. If we are the energy that we are getting in our muscles, from where we are getting it? We are getting by eating food, and food has what energy? Chemical energy. So the muscular energy comes from which energy? Comes from the chemical energy. So chemical energy gets converted into muscular energy. So I can say muscular energy is a form of chemical energy. So this statement is absolutely true. So muscular energy is a form of chemical energy. I hope you have understood. True, true, false, true, true. So only the third one is false. 1, 2, 4 and 5 are true. Okay. Now we come to the short question answers. There are total 5 short question answers. I cannot do all the 5 because most of them are easy. Those are direct questions. Some questions are just like state the other forms of energy other than mechanical energy. I think you know it is chemical, light, sound, magnetic, whatever energy. So I feel if I do these 2 questions, that will be enough for you. First question: name 2 things which store chemical energy. 2 things which can store chemical energy. Chemical energy is stored in, I told you, food. So any food is one thing which can store chemical energy. Any kind of food. Even a potato has chemical energy. And another thing, 2 things, na. Another thing, what you can say? Batteries, cell, batteries, cell, firecrackers, okay, crackers. Lot of examples are there which stores chemical energy. Now this question, give one example of work being converted into energy. Okay, so work is getting converted into energy. So I need to give one example to show this thing happening. See, I told you, if this is a one body is at a height, I am lifting this body up. I am lifting this body up. Now what I am doing? Think what I am doing. If I am lifting this body up, I am doing work. So I am doing work. And so how much work I am doing? 100 joule of work. I am doing 100 joule of work. That 100 joule of work that I am doing. So my body is losing 100 joule of work. And that 100 joule is getting converted to what? That 100 joule of work that my body, that I am doing, that is getting lost from my body, is actually gained by this marker. This marker is gaining that 100 joule. By how? As it is going up. Now this marker has what? This marker has potential energy. So now the marker has what? 100 joule of potential energy. So see, my work from my body is got converted into potential energy. At this point, no energy. I have full 100 work. Now as I'm going, my work is decreasing. From 100 it is becoming 90, 80, 70, 60, like that, going down. And over here from 0 to 10 to 20, ultimately my energy becomes 0. The work I have fully done, and that is converted into potential energy. So when you lift any body, so when you are lifting a body, the work is getting converted into energy. So what is the answer? Example: by lifting a body, work gets converted into energy. Work converts into potential energy. So by lifting a body, the work actually gets converted into potential energy. So this is the short question answer discussion. Now we'll start with the long question answer. Now, these are the long question answers. First question, what is potential energy? Potential energy is what? The energy acquired by the body due to its position. The energy acquired by the body due to its position, or due to its height, or due to its condition. So I'm just writing the general statement, okay? Energy due to position. The energy due to position is called potential energy. In what ways can a body acquire potential energy? So if you happen to two ways, suppose say if you lift a body to a certain height, if you lift this body to a certain height, the body will acquire potential energy, gravitational potential energy. So this is the first way. Okay, so what you can say, the first one is over here, what? If you lift the body at certain height, a height. If you lift the body at certain height, you can acquire gravitational potential energy. And second thing is what? When you happen to stretch or compress a body, when you stretch or compress, when you stretch, so when you compress, when you compress or stretch a body, like you compress a spring or stretch a spring, you stretch a bow. So that time also the body happens to acquire potential energy. Okay, so in what ways a body can acquire potential energy? There are three ways. One is what? A body is raised to a certain height. Second thing is what? The body is compressed. Third thing is what? The body is stretched. You stretch a spring, potential energy. You compress a spring, potential energy. You raise the body to a certain height, potential energy. Now, give one example to show potential energy gets converted into kinetic energy. I think we have shown the example. What? If a body falls, if this body happens to fall, when a body falls, now over here the body has what? Potential energy. As it falls, the body has what? When it's falling, body is in motion. When it is in motion, the body will have kinetic energy. So over here potential energy, as it falls, kinetic energy. So all the potential energy of the body over here gets converted into kinetic energy. So I can say what? When a body falls from a certain height, when a body falls from a certain height, all the potential energy gets converted into kinetic energy. Now the second question, what is kinetic energy? The energy acquired by the body, energy due to motion. The energy acquired by the body due to the motion is called kinetic energy. Okay, if it's motion, kinetic energy. Give one example, illustrate how kinetic energy can be utilized to do useful work. This is given in a book. Say in a water mill, the water mill rotates. How the water mill rotates? The water which is flowing, it makes the water mill rotate, and if the water mill rotates, the wheat will be grinded. So this is one useful example. Or else what? Or else moving air, wind. Moving air means wind. The wind turns the windmill, and when the windmill turns, what is produced? Electricity, and electricity is good for us, useful work. So you can say what? Example how kinetic, and so I can write kinetic energy of the wind turns windmill, and windmill produce electricity. So you can write over there. Okay, kinetic energy of the wind turns the windmill, and when the wind, and after, thereafter the windmill will produce the electricity. That is a useful word. So these are the one first and second question of your long question answer. Now question. Now this is the third question, I think so. Third question of long question answer. What is chemical energy? It's a very direct question. I think I explained that in the first or second lecture. That energy is stored in a matter which can become available for work by some chemical process. Like what? Like you take kerosene. Kerosene is a matter. Now, if we burn the kerosene, so if we burning the kerosene, what we are doing? We are doing certain kind of chemical process, and that chemical process that we are doing, that is the burning. After that, what is happening? When we burn the kerosene, heat is produced. By that heat, we can do some work. We can cook the food or something or the other. We can do certain kind of work. So energy stored in a matter which is available for work by some chemical process is called as chemical energy. This is a straight cut definition. You just need to understand the definition that chemical energy, what energy is stored in matter. A matter has chemical energy. It is stored in the matter. The chemical energy is stored, and that is available to us for some work. How it is available to us for some work? When we do some chemical process on it, by burning it or doing something like burning is a chemical process, and that energy we can obtain. So I think this is the straight cut question. Now, very good question. I think it is easy also. Give one example to show how it can be converted to work. So first question is chemical energy, how it can convert into work. Give one example. The best example is food. The food has what? The food has chemical energy. When we eat the food that we eat, after eating the food, what happens? Our body gets the energy and we can do some work. Without eating food, I think no, none of us can do any kind of work. So, eating food, consuming food converts the chemical energy to work. So, I can just write in over here what? Consuming food converts the chemical energy inside the food, and we can perform some work after consuming the food. Second, chemical energy is getting converted into heat energy. Heat. I think this is very easy example. Okay. Burning any kind of fuel. But when you burn any fuel, suppose you burn coal. When you burn coal, what is happening? All the chemical energy inside the coal getting converted into heat energy. When you burn petrol, what happens? The chemical energy inside the petrol converts that into heat energy. Okay. So when you burn coal, petrol, all the chemical energy gets converted into heat energy. Now last question is what? Chemical energy is converted into mechanical energy. Give one example to show chemical energy gets converted into mechanical energy. Simple. When we burn the petrol, the chemical energy of the petrol first burns into heat energy, and that heat energy what? It drives the vehicle forward. So if it's moving, it makes the vehicle move. Then what energy is there inside the vehicle? Mechanical energy. I can say kinetic energy. So the kinetic energy is actually a kind of mechanical energy. So when we burn petrol, the car moves. So when you burn petrol, all the chemical energy of the car gets converted into heat energy, and that heat energy drives the engine, and because the engine works, the car moves. If the car moves, then if the car is moving, then what it has? Kinetic energy, and kinetic energy is a form of what? Mechanical energy only. If you have learned, mechanical energy has two forms, kinetic and potential. So this is the example of that. Now question number 4, 5, 6 I am not doing because those questions I have already given notes or I have explained. Like after this, what is the next question? If I am not wrong, state the law of conservation of energy. See the previous lecture number 5. Conservation of law of energy has been fully explained to you. What is law of conservation of energy? Energy can neither be created nor be destroyed, just converts from one form to another form. How does a simple pendulum illustrate the conservation of energy? I think I have explained that in the previous video. In a simple pendulum, potential energy converts to kinetic energy, then kinetic to potential. Even the notes that I will be supplied with this lecture 5 and 6, in that notes, that answer show an example to illustrate an example to show how the simple pendulum conserves energy. It has been clearly written. So go through the notes, go through the lecture, previous lecture on part 5. These things are explained very clearly to you. Next question, series of transformation of energy during the production of hydroelectricity. I think 2 times I already explained. During the production of hydroelectricity, what happens? First, the potential energy of the water converts into kinetic energy, then the kinetic energy happens to convert into electrical energy. So that is also explained to you in previous lectures. Go through the lectures, previous video. All you will find, even the notes also have given that how the production of conversion of energy during the production of hydroelectricity takes place. Potential to kinetic, kinetic to electrical. Notes have been given, taught in the video. Go through all of them, you will get the answer. And last thing, explain the working of a roller coaster. Working of a roller coaster. I think I clearly explained that in lecture number 3 or 4. I'm not sure about that, but I have clearly explained how a roller coaster make loops like this and how the kinetic to potential, potential to kinetic, kinetic to potential, potential to kinetic, all this conversion of energy takes place. In even I have given notes of that also. See the notes that I'm supplying, or if you had in the book also it is written. From the book also you can find, in my notes also you can find the answers are clearly given, and the explanation already how the roller coaster works is I have explained that in the videos. So by this we have completed the chapter energy, but it took me 6 lectures to take. Now it is your job to go through each and every video, and when you watch it, watch completely. Watch all the videos from first to last. And after that, do your question answers. Do your question answers. Don't submit those question answers in that Jojo app. Write the question answers on the copy. When the school will reopen, we'll take the copies for correction and I will correct and give it to you. So don't submit in this Dojo app. It is very confusing because 150 students where and how. It's really confusing for me to get the answers. But write the question answers in the fair copy. Normal copy, don't make it interleaf. Normal ruled copy, both side. You write the question answers. So what you will write? Only the short and long question answers. Only the short and long question answers you will write in your note copy. You don't need to write the fill in the blanks, true and false, multiple choice question. No, only the short and long question answers you write in your copy freshly. Okay, so we expect to meet again in different chapters. So till then, goodbye, take care, and if you enjoy the video, please like. If you have any doubts, comment. If you want the videos of the next chapter, subscribe. And if you want your friends to also improve, share. That's all I have to say. Okay, bye, take care, good night.